So I told Mitran that today we are going to talk about how to find the area of a parallelogram. He said that I know it's base times height. I said okay, but why? And how do you know that this is correct formula? So he said, okay, why do we have to actually prove that the area of a parallelogram is base times height? I said because now that is where I'm trying to conclude that okay, if we learn any formula, somebody says okay, area of a triangle is half into base into height. Okay, you'll memorize it and you'll solve 100 sums. Tomorrow I said okay, area of a parallelogram is base times height. You'll try solve 100 sums. 2 years down the line, you come across a situation, you are doing higher studies, but then you have to still deal with some calculation where you have to find out the area of a triangle. And you forgot that formula which you had just memorized without understanding. So that is why when we prove or when we dig deeper into the formula to find out what led to the origination of that formula, that is when that becomes a concept. For formulas you can memorize but you can forget. Concepts you cannot memorize, you cannot forget. Concepts is what you understand. Let's say when we grow up, right, from a toddler to a child to a teen and whatnot, right? Do you think we memorize everything? No, we don't. We try understanding things. If you look at a 5-year-old kid, you will see that child asks a lot of questions. Is it to memorize? No, it's to understand. And because the child is small, it takes him or her a little bit of effort to understand what is being told to him or her. That's why the child keeps asking questions again and again. And it is an attempt to understand things, to get the concept. That okay, if you feel hungry, you should eat. But why? That's what the kid says. Why do I need to eat? So no, because when you feel hungry, you have to eat, otherwise your digestive system will start retaliating. You will get sick, you will become weak, you will not be able to play, you will get gas also which will hurt you further. So when you give all the examples, then that kid relates, okay, I'll get sick, I will feel weak, I'll not be able to play, I'll not be able to watch TV. Oh, that's a problem. So you're making the kid understand. This is the concept part of it. I heard Arav saying something. Arav, you were saying something about the area of parallelogram?
Yeah, so when you do the base times height, it's like a triangle. You're doing the first thing.
Okay. I thought you know the answer, but that's okay.
Wait, what was it? It was like
Why is the area of parallelogram base times height?
because it's related to a rectangle.
Okay. That's a subjective answer. I will not take that. That doesn't help me prove that. Okay.
Last class we proved that a parallelogram is two congruent triangles, and a triangle is, you find the area of a triangle is 1/2 of base times height. Since there's two, it would be base times height.
So basically, that's a reverse of what I'm looking for. So now, again, I will ask you the same question. Why do you think area of a triangle is half into base times height?
Because using two congruent triangles, you can most of the times make a square, parallelogram, or rectangle. Most of the times.
That might be a relatable answer, but not a convincing one. So let's do that, okay? So Srivastava, the two questions that we're trying to answer here. What is the area of a parallelogram? What is the area of a triangle? And we all know the formula for that. We know area of parallelogram is base times height. We know the area of a triangle is half into base times height. But I have $1 million question, why? Why it is base times height? Why it is half into base times height for a triangle? Okay, alright. Take care, make sure you're not running on the road. Okay? Bye bye, friends. Now, That's what we are trying to prove. So how come the area of a parallelogram is derived as base times height, and how come area of a triangle is derived as half into base times height? You know, you understood what I'm saying, right? See what's up? This is our plan for the day. Okay. Now, let's play with it. I have a base, okay? Let's say AB. I'll prove this in a roundabout way, okay? I have another parallel line like this. So AB is one line. This is my parallelogram, ABCD. When we say parallelogram, by now we have learned that in any parallelogram, it is a parallelogram because the opposite sides are parallel to each other and they are also of same length. That's what we have seen so far. Okay. So any parallelogram, be it a rectangle, be it a square, be it a rhombus, be it any kind of parallelogram, it is a parallelogram if the opposite sides are equal and parallel to each other. Simple. Yeah. See what's up? You are with me so far?
Yeah.
Okay. So any parallelogram, the main property that we have to remember, based on whatever we have learned so far, is it's a parallelogram. If it's a parallelogram, the opposite sides will be equal and parallel to each other. Simple. Okay. Now let's look at this parallelogram ABCD. I'll put a C here and a D here. Let's say it's a parallelogram ABCD. I'm not enjoying this guy. I'll make another parallelogram. So I made another parallelogram ABEF. What you see here is between the two parallelograms that you see, ABCD and ABEF. Okay?
It's kind of translating.
Translating?
Yeah.
Don't jump yet. Don't jump to the conclusion yet. I'm just giving you guys one more feed of information, okay? I'm saying that I had one parallelogram ABCD. I made one more parallelogram, okay? Because I did not like the first one. But what is that you see here between the two parallelograms? Both have the same base. One side is common between both of them. And these two parallelograms are made between two parallel lines, meaning this line and this line are parallel, right? So if you look at EF, that is also parallel to AB, DC, that is also parallel to AB, and actually both the parallelograms, one side fall on the same line actually. Yeah? It's like these two parallelograms are made between two parallel lines. That's what you can say. Yeah? So they have the same base and they are between the same two parallel lines. That's what you have seen so far. No guesses, no assumptions, no forceful application of any thought so far. Yeah? You are with me? See what's up? You are with me?
Yeah.
Okay. Now, what do you see between these two parallelograms? This area is actually common between both of them. Yeah? Now, is this triangle and this triangle of same size? Are they same in area?
They look the same, but the measurements are not given.
They are not given.
Yeah,
And
so
I
we
will
don't
not
know.
give that.
They look almost same, but probably different areas. They share common tools. The original parallelogram lines are common between the two. They have then the common one angle, one angle, one angle, one angle. So they have ASA, meaning they're congruent.
So, see, Pranit is thinking in the right direction now. He said, I asked about all of you, right? that is this triangle and this triangle same in area? And he said that probably yes, they seem to be congruent. And if I have to prove two triangles congruent, I look at three options: ASA, SAS, and or SSS. Meaning two angles and the side between them, two sides or the angle between them, and all the three sides. That's what, because once we prove that these two triangles are congruent, that means they have all the matching angles, they have same area also. If we can apply that formula, the theorem of congruence, we can probably prove that. Now you look at this. This side and this side is from the same parallelogram, so they are equal. They are equal and they are parallel. Yeah?
Yeah.
That means this angle and this angle will be also same, because these are corresponding angles. These are two parallel lines and these are corresponding angles. Even if you don't want to worry about the angles, forget about the angle. This side and this side are same because they are part of the same parallelogram, opposite sides parallel and equal. See what's up? Are you with me?
I have a question. What do you mean by same, like congruent or similar?
Congruent.
Oh,
When you say congruent, right? Congruent is nothing but an exact replica. If I say two triangles are congruent, meaning they are exact replica of each other. If you just rotate them and align them properly, they will completely overlay each other. Meaning they will have sides matching and they will have angles also matching. Okay? So when I say congruent, if you can prove anything congruent, you can simply say they are exactly the same in all the dimensions. Okay?
yeah.
So we have not proved congruence yet, but we have started thinking on those lines. Meaning, I had one parallelogram ABCD. I made one more parallelogram with the same common base and between the two pair of common parallel lines. Now we saw that between the two parallelograms ABCD and this one, this area is common. Okay. Then what we are left with is this triangle and this triangle. We are trying to see if this triangle and this triangle are congruent. If they are, what we will prove? That this parallelogram's area and this parallelogram's area is the same. But before we jump the gun, we'll see if we can prove that. So we are looking at this triangle DEA and triangle BCF. What do we find among them? Let me make it a little cleaner. It's looking very clumsy right now. Okay. So you can see the board, right, Shivatsa?
Yeah.
Yeah. Okay. So we are looking at this triangle DEA and triangle CBF. Okay. Now this side and this side are same. Agreed? Because this is part of the same parallelogram, opposite sides, parallel and equal. Now look at this side and this side. They are also the same. Yeah? Because same parallelogram, opposite and parallel and equal sides. Now let's look at this piece. This side and this side. Now look at this parallelogram. Okay? ABCD. This DE. What's AB will be equal to DC. Agree? Same parallelogram, opposite sides, parallel and equal. Similarly, if you look at second parallelogram, again AB will be equal to EF. Now DC is equal to what? DE plus EC. Yeah? Again EF equals to what? EC plus CF. Are you guys with me so far? Shivatsa, are you with me?
Yeah.
Okay. Now EC and EC. See, AB. Okay, let me not rush. So here you see AB equal to DC, AB equal to EF. So what you can say? DC equals to EF, or don't even say that. Both this is AB. You can say this equals to this. Can you? D plus EC equal to EC plus CF. Because AB equals to DC in the first parallelogram. Second parallelogram says AB equal to EF. So if I break it down, what I get is EC gets cancelled out. DE equals CF. DE equals CF. So all the three sides between the two triangles are matching. What is happening is that makes this triangle and this triangle congruent. If it is congruent, that means the area of this triangle is equal to the area of this triangle. What that means? The area of this parallelogram, which is addition of this plus this, and area of this parallelogram, which is addition of this and this, are also same. Am I making sense so far? No, it's okay. I can go over this one more time. Because I'm trying to draw some conclusion from this, okay? And that will be like a conclusion that you will be surprised to know about. Here, I had one parallelogram, ABCD. I made one more parallelogram within the same pair of two parallel lines and the same base. So I have two parallelograms now, ABCD and EFAB, this one. From whatever we have done so far, we found that this first parallelogram has two things, this area and this area. Second parallelogram has same two things, this area and this area, this triangle basically, yeah. And this part is common, and this triangle we just proved congruent. That means area of this triangle is matching. What that means is this parallelogram's total area is same as this parallelogram's total area. That is a magical conclusion that we can draw from this. And you can look at the video one more time and try proving it yourself. When you sketch it, when you draw it on a pen and paper, with a pen and paper, you will do that. What I'm trying to conclude from this is that if I have one base and base line, okay, line segment I would say. If I draw a rectangle ABCD, or I draw a parallelogram like this, or I draw another parallelogram like this, everybody's area will match, meaning
It kind of looks like the rectangle is kind of rotating a bit.
yeah, rotating or getting squeezed
Yeah.
or aligned, or it's like you would have seen the toys, right? You have like a block, you twist it, turn it, kind of thing. Same thing is happening here. But the conclusion that you can draw from this is that if you're using the same base and making parallelograms with the same, with one pair, within the two pair, within a pair of parallel lines, the area of all the parallelograms will be the same. So, be it a rectangle ABCD, or be it ABEF, or be it ABKL, area of ABCD will be equal to area of ABEF will be equal to area of ABKL, and you can just go on. If you are not liking it, go in this direction, make a parallelogram. If you use the same base and within the same two pair of parallel lines, if you draw n number of parallelograms, everybody's area will match. If you're really in a playful mind, playful state of mind, and you say, okay, fine, I will use my line segment like this, and I want to literally enjoy it like this. Okay. So, if you are really being playful, this area will be same as this area. Okay. I mean, maybe I have not drawn it properly, but what I'm trying to say is, if you are drawing n number of parallelograms between the same two pair of parallel lines and with the same base, your area will be the same. This is one takeaway that you will remember for rest of your mathematical journey. That if you have the same base and you are drawing parallelograms like this, the area of this will be same as area of this. We just now proved this, right? Now look at, so what we're saying is, area of this parallelogram will be same as area of this, which is, this is base, this is my base, and this guy is nothing but my rectangle. Okay, what is the area of a rectangle?
Base times height.
Base times height. Here the height is nothing but the perpendicular distance between the two parallel lines. So also, are you with me?
Yeah.
So, any parallelogram's area is base times the perpendicular distance between the two parallel lines. If you pick this as a base, then your perpendicular distance will be this, right? Since we are taking this as a base, make a rectangle, base times height. That's the area of a parallelogram. So now in future, if anybody says that memorize that area of a parallelogram is base times height, you will say, I don't need to memorize, I know how it is derived. Okay? So far, are we good? Is this sounding boring, interesting, eye-opener, eye-closer? What is it? Good? Is it a good information? Okay? Does this, because I keep saying that, okay, don't trust me just because I'm a teacher. Because math is the only subject that doesn't require you to trust anybody. You have to just do it. Do it by yourself. Question yourself, question your teacher, why? Because when you get your why answered with the reasoning, that's why I was saying, area for a parallelogram is base times height. Why? This is why. This is the answer to that why. Now, Shivatsu, what do you think?
Yeah.
So area of parallelogram will be remembered forever. Yeah. Now, second question. Second question to which I had asked why again. Area of a triangle is half into base times height. Why? Okay. Now, there is one more theorem or concept that we learned in the previous class. Let's look at that. What that concept says, if I have a parallelogram and if I join the corners, what happens? It splits that into two congruent triangles. Any diagonal of a parallelogram splits that parallelogram into two congruent triangles. Be it this diagonal or be it this diagonal. It just has to be opposite corners being connected with a line. Yeah? See what's up? Are you with me so far?
Yeah.
So just to help everybody recall here, what we have proved or learned in the previous classes is that if you have a parallelogram, if you join the opposite corners of a parallelogram, that splits that into two congruent triangles. If you don't remember, we can look at it very quickly. This side is equal to this side is common, this side is common. Yeah? So if I look at these two triangles, this is a parallelogram ABCD, and when AC is my diagonal, that makes two triangles ABC and triangle ACD. Between the two triangles, if I see, this side is common, AC is common, so AC is equal to AC, don't have to say that. This is a parallelogram, so opposite sides are equal and parallel, so AB equal to CD and parallel to each other. This BC and AD are also parallel and equal, so all the three sides are matching. So this uses SSS theorem to say that these two triangles are congruent, meaning what we can confirm as a statement is if you have a parallelogram and if you join two corners or or any diagonal of a parallelogram splits that into two congruent triangles, meaning two triangles of equal area, two triangles of matching dimensions, two triangles of matching all angles, meaning a replica of each other. So that means I can say area of this triangle, if I have to say area of triangle ABC will be equal to half the area of parallelogram ABCD. Do you guys agree? What's up? Are you with me?
Yeah.
That means half of the area of the parallelogram, which is base times the perpendicular distance between them, or the height, whatever you call it. So same thing, this height is the height of the triangle also. So this formula of area of a triangle equals half into base times height. This is from where it comes. Now you will say that okay, I took you guys around and then tried proving it. Let me pick up any triangle. This is a triangle. What will I need to do? Draw a parallel line to this one. Okay? And draw a parallel line to this one. This is my triangle ABC. And when I do a parallel line to AB and parallel line to BC, they cut each other at D, let's say. This is my parallelogram. So area of this triangle will be half of the area of this parallelogram. So half into base into whatever is the height, the perpendicular distance from here to here, or the perpendicular distance between this and this parallel line. Okay? I can guarantee you guys that if there was a 10% possibility of forgetting the formula for area of parallelogram or the area of a triangle, that risk of 10% forgetfulness is taken care now. I don't think you guys will ever forget this now, unless you want to. Yeah? So here's the thing. Our attempt would be, whatever we learn, we would always try to question ourselves or ask ourselves. There could be times when you'll ask me, okay, how come this formula came into light? And if I'm not able to explain that, I'll find out how to explain that. Because one thing is for sure, any exam, be it SAT, be it your class exam, be it any competitive exam, things revolve around the concept. How many problems, see, if you have, let's say, people say, okay, 10 problems. Question number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. People give you 10 questions on area of a triangle. First question says base is equal to 5, height is 20. Find out the area. Second question says okay, area is equal to 200 square centimeter, base is equal to 20. Find out the height. Third question says height is 2 times the base and base is equal to 20 centimeter. Find out the area. They can do all the tweakings. Okay, change the wordings, change the disposition. What doesn't change? Area equal to base. Area of a triangle is base times height. Okay. You know this is my core, and you also know how this is arrived at. Regardless of how much people play with this, I will only use this to solve all the problems. You guys remember what is time? Who doesn't?
Trust yourself.
Mm-hmm.
Read the question.
Again and again,
And again. Analyze.
and then and
Nike,
just do it. So what I'm saying is, this is your mental alignment. This tells you how would you approach any problem. Now, I am the same person who teaches the kids from 3rd to 5th grade, which is level 1. I'm the same person who teaches kids from level 2, 6th to 8th grade. I'm the same person who teaches kids for SAT preparation also. Okay? Formula changes, everything, equation changes, the level of complexity changes. What doesn't change is this. Any question that I come across, any question my students come across, I say, okay, fine. Trust, you have to keep it with you. You have to always believe. But don't compromise on reading the question. Read the questions enough till you are sure that there is nothing else that you are missing. Don't start jumping to solve the problem. You first understand what is there to solve. Your effort has to go to find out all the clues from the question that you have. That's why it's very important to read it over and over again. I might be sounding very stupid to you guys, okay? I'm on recorded video, it goes on YouTube also. I might sound stupid, but trust me, these are the basic building block of any math question or attempting any math. You have to read the questions enough. It might so happen that you will, once you get into the practice of reading the question again and again, and you study for some time, you practice enough, then there will be some intelligence that you will build to read the questions faster, to get the clues faster. But then still, regardless of your intelligence level or the time you have spent, you still have to read the questions. There will be kids who will be able to read the question one go and get all the clues. There will be there will be kids who will have to read it 4 times to get all the clues. What matters is the right answer. Nobody knows how many times you read it. But more you read, better it is. And once you read it, then you do all your mind math or do all your calculation, do all your analysis to say, okay, fine, this is how I'm going to approach this problem because this is the information I have. And then you attempt to solve it. This is Nike. When you have come to the Nike stage, there is no brain that you have to use. It's a manual effort because you have done all your intelligent thinking, analysis, reading before that. Okay? If you start on the end first, the analysis you are compromising, you might think in the wrong direction, you might go wrong with your approach. Anything will happen. I mean, you might do right also, but yeah, there is no guarantee. More guarantee comes when you do your homework right. Okay? So here on this point, again, I got a little distracted, but what I was trying to say was, any concept that we learn, we have to put a lot of energy to learn the concept, what it is, how it is coming to light, what is there that I am understanding from it, and how. Let's ask enough questions to ourselves to understand the underlying concept first. Once you know that, then whether you do 5 problems or whether you do 25 problems, this is your brain of the problem actually, or brain of the concept that you have learned. You cannot go wrong here and then solve problems. That's why I do not give lot of homework to you guys. The reason being, I put my focus and energy on making you guys learn the concepts and enjoy the concepts. I'm not sure if you guys notice that, but when I'm explaining the concept, there's a sense of satisfaction in my face. I smile because I feel that. It gives me that comfort that yes, I'm not making you guys, or I'm not forcing you guys to learn something or memorize something just because I want you to. That doesn't have much life to it. You guys will start hating me if I start forcing you guys to memorize formulas actually. Yeah? That's not the right style of learning, and I don't prescribe that. I would not do that. The day I start doing that, I'll have to quit. Okay? Yeah? So far, a summary of what we have done so far is, we have looked at how area of a parallelogram is same if they are built or they are constructed within the same pair of parallel lines and the same base, a common base. And that is how we proved the area of parallelogram is base times height. Then we looked at proving the area of a triangle is half into base times height. And how is that? Right? That also we proved. It was relatable. I mean, it was not as big a definition like what we did for parallelograms. And then we just looked at some of the scenarios, right? I mean, again, these are possible sums that you will deal with when you're dealing with a parallelogram. Somebody says this. See, people can make it more tricky by adding more storylines to it. Okay? But your underlying concept will not change. Before I move further. So, see what's up? Any doubt, any question, confusion before I move
No
forward?
doubts. No doubts, I guess.
Okay, that's good. Now, let's attempt some problem. Okay. I love building problems. This is a parallelogram. Let me put it this way. Find out the area of this shape. It's a little trick question, but worth trying. So, see what's up. This is the question I have. I want you guys to solve it and find out the area.
Area, right?
Yeah. So, let me make it a little clear to you guys that this length from here to here is 3 centimeter, and here to here it is 18 centimeters. Okay, I want you guys to find out the area of this one. Yeah. So the base is 18 centimeter. I have drawn a perpendicular line from this is base is 18 centimeter. This parallel, this line is parallel, so 10 centimeter. This side is 8, this side is 5, and I have drawn a perpendicular line from here to here, and this length is 3 centimeter. I want you guys to find out the area of this shape.
Wait, can you show me that? Like, can you?
Can you see it? This is the base, 18 centimeter here to here. This top one is parallel to the base is 10 centimeter. This side is 5 centimeter. This side is 8 centimeter. And I have drawn a perpendicular from here to here, and it cuts at this point, and this length is 3 centimeter.
I already got my answer.
Okay. Show it to me.
Okay, so here's what I did.
Okay,
Can I
good.
whisper to you?
Yeah.
Okay, so what I did is, since that looks like a trapezoid, I used the trapezoid formula, base 1 plus base 2 times the height, and I found out that this triangle is kind of like a Pythagorean theorem part. So then I noticed that height is 4, so it did 18 plus 10 times 4 divided by 2. So then I did 28 times 4, then I crossed changed to 1, crossed that, changed it to 14, then did 14 into 4, which gave me 56.
No, this is correct. This is correct. This is one way of doing it. Let's see what Pranit and Srivatsam do. This is. I mean, you solve it because you looked at this as a trapezoid and you solved it. Okay.
Yes.
I mean, that is one way of doing it. But that requires me to remember the formula, which I mean we all remember for sure. But I would want to see it. Yeah.
Can you tell me like the length of perpendicular line?
No, that is what you have to derive.
Oh, okay.
So, if you have to go anywhere, Mitran,
What time is it?
it's 5:45.
Well, I don't have anything today.
Oh, okay. Then wait for the class to get over, because I'm going to teach another way of solving the same problem. Let's see what Pranit and Srivatsam do based on that. Based on that, we will. After Pranit and Srivatsam are done, then we'll end the class. So while Pranit and Sivatsa were trying to solve this one, Mitran, can you think of any alternate way of solving this based on what we have learned today?
Okay.
Try that and see. You can match your answer. I mean, regardless of which approach you take, your area has to be the same. Try finding out through some other means and compare that area with what you have got already and see if both are matching or not.
Okay. What time is it?
5:47. We have 10 more minutes.
5:47. Okay.
Mhm. Done? I think you guys are overthinking. This should be a simpler problem.
I think I'm done.
You done? How much is that?
I don't know if it's combined right now, like 1395.
1395.
Yeah.
What is the total area? 1395.
Yeah.
Okay. No, it should not be that much.
No, I didn't know like if it's a combined shape or like a same shape.
It's the same shape. It's from here to here. Full shape. I'm saying what is the total area?
Also, the perpendicular line is just like the height.
Just the height, yeah.
Oh.
I mean, this is just to depict that this particular line is drawn and this is making, this is cutting at 3 centimeter length. Yeah.
I know that if the hypotenuse is 5, this is 3 before. So this would get you 6 here, right?
This will be 6.
This is the area of this one.
Okay.
Since that means this is 10, so there's 10 here, 3 here, so that's 13. 18, so that 13 is 5 here. 5 is 8. Then using Pythagorean calculus, 6.3.
That will see that this height here and here cannot be different.
So if this is 4,
Yeah.
4, 5, 8.
So here you probably not use the Pythagorean theorem. I mean, maybe there is something wrong with the shape. So maybe when I'm saying 8 centimeter, this is much longer here. Okay. So this base might be more. So okay. I don't want to make your evening longer. Let me solve it in a simpler way.
I
Yeah.
think I got the perpendicular line height. It's 16, right?
What is that?
16. Perpendicular.
Perpendicular distance? No, it will be 4. It's a Pythagorean theorem, right? So 5, 3 and 4. 3 square plus 4 square equal to 5 square. This is 3 square and this is something. So 3 square plus something square equal to 5 square. This is what the Pythagorean theorem says. So x square equals to 5 square minus 3 square, which is 5 square is 25, 3 square is 9. So x square equals 16. So x is square root of 16, which is 4.
Square root is
4.
4.
Yeah.
Yeah. Yeah. I didn't convert it to square root. It's
Yeah. Okay. So now tell me what is the area of this guy. So let's solve it. Okay. I'll anyways give you guys assignment, and that will make you guys practice as well. So now I remember this is 3 centimeter, and here to here is 18 centimeter. So there are two ways of solving it. One way is what Smithson was doing. say okay, this is trapezoid because they are by definition a trapezoid is a quadrilateral which has only one pair of lines parallel to each other. That is, this line and this line are parallel to each other. So area of a trapezoid is equal to half into sum of parallel lines into perpendicular distance between them. Yeah, the parallel lines. That's what the formula is. So here you will say half into sum of parallel lines, which is the 10 plus 18 makes it 28, into the perpendicular distance that you found by the Pythagorean theorem. This is 5, this is 3, this is 4. So 4. So this makes it 28 into 2, which is equals to 56. 56 centimeters square. This is one area. Now, Shivatsav, were you able to follow me?
Yeah.
The first approach is by using the formula for trapezoid. That's straightforward. Now, second thing is where you can get into creative. What you can do is, you found out this is the length of the perpendicular distance between them. Now, you draw a line parallel to this line. Where will it cut? This length will be how much? 10 centimeter. You literally made it a parallelogram and a triangle. Okay? So now this length is 10 centimeter and this length is what? 8 centimeter. Yeah? Because I made a parallelogram, right? I drew a parallel line to this one. So wherever it cuts, this length will be same as the length of this line. Yeah? So now I have a parallelogram and a triangle. Area of a parallelogram is base times height. This is my base, this is my height, which is 10 into height is 4, which is equals to 40 square centimeter. Okay, this part, the area of the parallelogram is 40 square centimeter. Now this one, which is half into base into height. My base is 8 centimeter. Half into base is 8 centimeter into height is 4 centimeter. This height and this height are the same, right? So this is half into 8 into 4. 8 4 is 32. Mine by 2, 16. So 40, 16 centimeter square. That is 40 plus 16, 56 centimeter square. This is matching with what you had got. Yeah. So regardless of which approach you take, you should get the same answer. And that is your way to validate. So that's why I was saying you guys are probably thinking too much. The only clue that I had given you was this Pythagorean theorem. You had two options. Convert this into a trapezoid. Think of this as a trapezoid and use the formula. You needed the height. See, any parallelogram or a triangle that you talk about, if you look at the area, what you need to know is the base and the height. And this was my only clue to you, where I clubbed this with the Pythagorean theorem so that you can derive the height. I could have as well given you 4 centimeter. I wanted you guys to think. Once you get this one, then imagine this as a okay, I know the formula for parallelogram. That was the second clue I have given you guys. That you can apply all that we have learned. And we have learned only two things today. One is area of a parallelogram, area of a triangle. Not that we learned, we just learned how to derive that. So I just applied that here in this one to find that amount. Okay? Does that or did that make sense to everybody? Mitran, did that? So any mathematical sum you can solve in n number of ways, whichever strikes at that point in time. You don't have to think of me as the right answer provider or you being right or wrong. At that very moment, whichever option works, just go ahead with that. You just have to make sure that you are thinking the right direction. Okay? Srivatsav, did I explain it okay? Did you understand it?
Yeah.
Yeah? So now the punchline of the day. The punchline of the day is, when you look at questions, any mathematical questions, what is our first perception about it? Oh, this question is easy, this question is difficult. Don't think like that. Always look at a question as an opportunity for you to find the clues. Because the questions are actually meant for giving you clues. We think of it other way around. Clues are clues. There will be some hidden information that you have to derive by reading through it, going through it over and over again. So whenever you look at or come across any question, don't stress out by thinking that, oh, I have to answer this question. Question is nothing but a clue for you. Imagine if there was no question, what was there for you to solve? Somebody has given you some clues and is asking you to solve that. So questions are not to get worried about. Questions are not there to haunt any of us. These are the only opportunity for us to solve the problem. So any question is nothing but a clue. That is my message to you guys, so that you start enjoying questions. Okay? If somebody is asking you a question, that is your only opportunity to get clues to be able to solve a problem. Okay?
Okay.
That brings us to the end of the class.